Hey, so in this lecture we need to set up input bindings and the basic movement logic for the basket pawn so that we can go ahead and collect those apples that fall from the tree. To begin, I will go to the project settings. I will go to the input section, and then we have the bindings right here. Notice the difference between the action mappings and the axis mappings. There's this helper at the top here. Action mappings are key presses and releases, such as pressing spacebar to jump in an FPS game. Axis mappings allow for inputs that have a continuous range. Range typically means that we are dealing with floating point values, such as -1.0 to 1.0. For this project, we will be using the A and the D keys and the left and the right arrow keys to move the basket to the left and to the right. That is to move our basket pawn in the positive right vector when the value is positive, or in the negative of that if the value is negative. Our input will have a continuous range, so I'll go with an axis mapping. I will click here to add an axis mapping, and I will name that. I will simply name that move right, because when we move in the positive right vector, then we will have a positive of 1, and if we move in the opposite direction of that, so negative of that, then of course we are going to move left. So now we can go ahead and search for those keys. We are going to use A and D. We need to think about what we want to do here. So when we press the D key, we want the basket to move to the right. So this is fine because it's going to move in the positive right vector, since this value here is positive 1.0. But when we press A, we want this to move in the opposite of that basically, so in the negative of that. So I'm going to modify that scale and set that to -1.0. Again, on the keyboard, I will select left and add another one here. Keyboard and right. And then we want to make sure that again we think about what we want to do. Moving left, we want to move in the opposite of the positive right vector. So we'll set left to -1.0. I would also like to note that you can export the settings and import them as well. And this is useful, of course, if you want to make a backup or if you want to use the same settings across multiple projects. Okay, but that is going to wrap up this section here. Now we'll go ahead and move on to coding the input in Visual Studio. Alright, I'll navigate to the basket base header, and we've discussed time-based movement before, and in this section we will do something similar to achieve the movement of our basket. In the protected section, I want to add a variable that we can use to keep track of the speed. Next, we want some variable that we can use to store the current velocity. Instead of using a float where we only keep track of a particular variable or part of a vector, we will use a vector. We will use this vector to keep track of the current velocity, that is the basket speed, multiplied by the axis value, either -1.0 or 1.0. Next, we need a function that we will bind to the key press, so that when we press the key on the keyboard, that is A, D, or the left and right keys, then we want to call that particular function. When we press those keys again, either we want to move in the positive right vector, or we want to move in the opposite of that, in other words to the left. And because this is an axis binding, it will take in a float. I will name the function that we will invoke when pressing one of those keys, move right, simply because again we are moving in the right vector, but of course we can also move in the opposite of that, in other words left. To save some typing, again I will use the quick actions and refactoring, and I will create the definition of move right in the basketbase.cpp. I will navigate to the constructor and initialize the variables basket speed to 700 and current velocity to 0 on construction. I will navigate to the basketbase.cpp, and in the setup player input component, the formal parameter is a pointer to a uInput component. I can right click on that and pick definition. Notice that it implements an actor component for input bindings. I will use that pointer parameter, which is called the player input component, and I will invoke the bind axis. Notice here I have bind axis and bind action. We want to bind axis. For the actual parameters, we want to specify the name, which is the name that we specified in the editor in the project settings. That is when we did the input binding. Move right. Pass in this for the second argument, and for the third argument, that is an if method pointer to some function. So we will pass in the function that we would like to bind to that axis, in this case the move right function. In the move right member function, remember this accepts a float, since it is an axis binding. It has a range of values, so it has a float axis value as a formal parameter. And we can use the parameter and multiply that by the basket speed. Let's say the axis value is -1 because the player presses the A key or the left arrow on the keyboard. You multiply that with the value of the basket speed, which is 700. That is what we initialize that to. That is going to give you negative of 700. Otherwise you get the positive 700, right? And in that way we change whether the basket moves left or right. I will log the current velocity vector by using the toString member function, remembering to use that asterisk operator. We will use this log in the editor for debugging shortly. Notice that at this point we are not doing the actual offset, we are just making these calculations. Also, this is not time-based since we are not using delta time, and instead of creating another variable to store the delta time and then having to use that in the moveRight function, we will implement the actual movement logic in the tick function. You typically have forwards and backwards, and you have up and down movement also, not just left and right. This is why I'm using an F vector for current velocity instead of a float. You can now use the A and the D keys to move the basket around. I'll just go ahead and play here in the viewport. One issue that you'll notice is that when we press and hold the A key and the left arrow keys together, for example, at the same time, then the movement speed will essentially double. It is going to pick up both key presses, and we don't want this cheat in our game, and we need to fix that. We can filter the output log. I'll just filter the output log here to warnings. Play this a bit using only the A key, for example, and the D key, and then using a combination of A plus the left arrow and then the D plus the right arrow at the same time to see what sort of results that we get. Notice that we get zeros printed out. That is when we are not pressing a key. Otherwise we get values such as -700 when we press the A key or the left arrow key. We also get +700 when we press the right arrow or the D key. Otherwise we get -1400 or +1400 when we press both of those together. So the A key and the left arrow at the same time, or the D key and the right arrow at the same time. And to fix this issue, we can navigate to the moveRight function. Remember that we are doing multiplication with this axis value, which is between the range 1.0 and -1.0, depending on what the player presses. So we can clamp the axis value, and clamping allows us to specify a valid range of values. If the value falls outside of that range, then it will get clamped or modified to what we specify. Notice in the tooltip it's going to clamp the parameter x to be between min and max inclusive. So what we want to do is we want to clamp the axis value, and we want to clamp between -1.0 and +1.0. Next, in the tick function, one final thing here, currently we are fetching the actor's location and doing calculations that are unnecessary in the case where we are not actually moving or pressing a key. For example, when a player does not press a key mapped to moveRight, then the value is 0 in the current velocity. And of course we don't want to perform those calculations unnecessarily. That is when the user does not press those keys, again A, D or left and right. Basically what we want to do is we want to check whether all of those components or members of the vector are 0, that is x, y and z. Thankfully we have a handy function for that, ES0, so I'll invoke that. ES0 will return true if the vector is 0. So what we want to do is we want to check if the current velocity is not 0. So if it is not 0, then do the actual offset. I will build and run and try to play. We will destroy those apples that are currently filling up our level in an upcoming lecture. Now if I hold those keys in combination, such as the A and the left arrow keys for example, the movement will not double.